Welcome to Chem Vid, Dimensional Analysis. This lovely little thing we are going to be using all throughout our chemistry lives, and you use it a lot in other situations, even though you may not realize it. But all dimensional analysis is taking a measurement in one unit and converting it to another unit. So like we did before, taking inches and converting it into feet, taking inches and converting it into miles, whatever you want to do. All right, so let's get started. So as we did before, we have 6 inches and I want to get it into feet. That's my question. So I know that there are 12 inches in 1 foot. And by knowing this, I can change it into a completely different unit. So what I want you to recognize here is when you start with dimensional analysis, you start with the initial measurement that you are trying to change. After the line, you use a conversion factor that equals one another. So in this case, 12 inches equals 1 foot. This conversion factor never changes. 12 inches will always be in 1 foot. So I'm never, ever going to change a conversion factor. The only thing that ever changes is the number that I start with the units. Another thing I want you to make sure you watch out for are the units. Units are extremely important, especially when you're trying to do chemistry. If I look, I am starting out with inches. Okay? I want to get rid of this unit. Now in math class, whenever I want to get rid of a number, let's say I wanted to get rid of a 3. I would divide by 3, and that equals 1. So if I take something and divide it by the same something, I get 1. It works the same for units. If I take inches and divide by inches, inches cancels out and goes away. That unit is no longer there. So then I'm left with feet, or the unit that I want left over. It's the only unit left. I use my conversion factor to go from one unit to another unit. The units that I don't want cancel out, the unit I want stays. And that's how I get the unit on my final answer. Then I just need to follow the numbers. Just like with fractions or anything like that, I take my number, I'm going to multiply by the top, and I'm going to divide by bottom. Okay, so these conversion factors are just like fractions. So I'm going to take 6 times 1 divided by 12. That equals 0.5 or half a foot. And that's how dimensional analysis works. It works the same way every single time. You just follow the units. All right? So let us look over at our notes and write out the pattern for dimensional analysis. So, for my pattern, I want to take the original measurement with the original units. I draw a line. Then I put the units that I'm trying to get rid of on bottom of my new ratio. And I put the new units I want on top. Now the cool thing about dimensional analysis is this can go on forever, changing units. So if I wanted to change it to another unit, I could just draw another line. I put sure the units up and below match so they cancel out. And then I have my new units. All right? So that's the first thing you should do. Set up your units and make sure you know where everything's going. Next thing, I have inside of these little, after the line, they're called conversion factors. A conversion factor is just the number of one unit has to equal the number of a different unit. So for instance, if this was inches and this was feet, I would have to make sure I found out how many inches are in a foot. So I know that there are 12 inches in 1 foot. If you've already put your units in, then it's no big deal. You're just putting your numbers in to match, and you will always multiply and divide with the correct numbers every single time. So now in my next proportion, let's say I'm trying to get from feet to yards. So I would just fill in the units. See, my feet cancel out because one's on top and one's on bottom. I need to find out how many feet are in a yard. I know there are 3 feet in 1 yard. So now I have everything I need. My units cancel out, and I'm left with just the unit I want. And I have the conversion factors that are equal to one another inside of these guys, in the ratios. So now I just have to do the math. Just like with a fraction, I'm going to take my original number, I'm going to multiply it by what's on top, and then I'm going to divide by what's on bottom. So in this case, I would take my original number times 1, divide by 12, times 1, divide by 3, and that's going to equal my measurement in my new unit. Okay? Now here's something that is really important. This measurement right here and this measurement right here are the same measurement. The measurement hasn't actually changed. The only thing that changed was the units. Okay? So the units changed, but the measurement, the thing that I'm measuring, it's the exact same thing I started with. Okay? Alright, so if you would, sometimes this seems like it's pretty easy and you jump ahead and you just try to do it your own way. I'm going to tell you something. If you want to be able to do dimensional analysis when it comes to the trickier chemistry stuff, you need to practice it now. So even if you can do these conversions in your head, I want you to write them out with dimensional analysis. And follow the steps. Write out the original unit and measurement. Write the units in your proportions after your lines. Fill in the conversion factors. Multiply across, divide by the bottom, and you will always, always, always get it right. Okay? So please practice this, even if you can do it in your head. Okay, so we're going to jump down to number 4 on your notes because they have new units. So we're going to practice with this one. And the question is asking, how many milliliters of apple juice does the company need in order to fill 2.5 pallets? So the first question is, what number do I start with? Well, I start with the number that I want to convert. I want to know how many milliliters are in 2.5 pallets. So I start with that, 2.5 pallets. And then I draw my line. And I know that pallets have to go on bottom because they must cancel out. Then I look over to my conversion factors. Well, I know 1 pallet equals 45 bundles. And I know that 1 can equals 218.4 milliliters. But I can't go directly from pallets to milliliters. So I'm going to do what I can first. 1 pallet is equal to 45 bundles. So I'm going to come back over here and I'm going to do bundles. And I'm going to put in 1 pallet equals 45 bundles. But I'm not done. I'm not to the units I want, so I'm going to draw another line. I'm going to put bundles on bottom so that it cancels out. And I'm going to look over at my conversion factors, and I see that 1 bundle is equal to 32 cases. Cases. And 1 bundle equals 32 cases. And then I'm going to keep going. See, right now, pause the video and see if you can get all the way to milliliters. Okay, did you get pallets to bundles, bundles to cases, cases to cans, cans to milliliters? If you did, very nice job. You got this down. Make sure you always put in your units first, then put in the numbers. If people start putting in numbers and units at the same time, there's more likely to be mistakes. So before I enter any of this into my calculator, I am going to check to make sure my units work out properly. So pallets divide by pallets. Good. Bundles, bundles. They cancel out. Cases, cases, cans, cans, and I'm left with milliliters, which is what I originally wanted. So I know that it works out. So now I am going to multiply by the top numbers, divide by the bottom numbers, and I am going to find my answer. Go ahead and give that a shot. My answer is 9434880, or 9,434,880 milliliters. That is a lot of numbers to write. And when we get into those big kinds of numbers, we like to use scientific notation or some other type of prefix. I don't want to go into another prefix right now, so I just put it into scientific notation. Ta-da! You have just said that in 2.5 pellets, it equals 9.4 times 10 to the 6 milliliters of apple juice. That's a lot of apple juice. All right, so that is how dimensional analysis works. Before you come to class, I want you to try number 5. All right, this number 5 right here. Change milliliters into cases. Show all your work using dimensional analysis, and please use units and circle your answer. Okay? But for now, let's scroll on down, or I'll scroll, you just turn over the paper, and I want you to jump to scientific notation. Alright, so a quick review of scientific notation. Scientific notation is based off of tens, so my number, when I use scientific notation, needs to be between a 1 and a 10. So it needs to be like a 1.5 or a 2.7 or something like that. It will never be 10.1 times 10 to the something. Okay? Never, 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 never. The first number always needs to be between 1 and 10. Remember, big numbers, or whenever you move your decimal place to the left, have a positive exponent. Small numbers, or whenever you move the decimal place to the right, is a negative exponent. Go ahead and try the example problems. Okay, so number 11, you should have gotten 4.5 times 10 to the 6th meters. Make sure you include your units, very important. Number 12 is 5.4 times 10 to the negative 3 seconds. Before class, I want you to try number 13 and 14. All right? Let's go on to addition, subtraction, multiplication, and division. Okay, so when adding or subtracting, it's really quite simple. Make sure the exponents are the same. If not, make them the same by changing the decimal. And then add or subtract the front numbers like you usually would, and put on the exponents afterwards. So let's give it a shot. In number 15, it says 2.2 times 10 to the 4th plus 3.2 times 10 to the 4th. My exponent is the same. So now all I have to do is just add the front number like normal. So I would take 2.2 plus 3.2 is 5.4. All right. And then I add the exponent on afterwards. Times 10 to the 4th. No big deal. But what if it was like number 16, where the exponents are not the same? So I have 7.3 times 10 to the 3rd. Now I need to change that exponent to a 3. So what I'm going to do is I'm going to take the decimal and I'm going to move it 2 over, so that I now have 525 times 10 to the 3rd. Now if you notice, that isn't correct scientific notation, but I'm just going to put it in that way so that I can add my two numbers. Then it stays the same. I add these guys together. 532.3 times 10 to the 3rd, just like normal. And then I'm going to move my decimal place back over so it is in correct scientific notation. And I'm going to put times 10 to the, moving it over would be 5.323 times 10 to the 5th, whatever you're measuring. Read the rules for multiplying and dividing, and try 17 and 18 without a calculator. Thank you for tuning in, and we'll see you next time.